So, after seeing the definition about gradient operator, here we have an example. In Cartesian coordinates x, y, and z, we can know the position of a point M by using position vector r. This r is exactly OM. We have my three axes, of course, x-axis, y-axis, and z-axis, and my point M is here, okay? And my origin. So my position vector is exactly OM equals xi plus yg plus zk. Question. Compute grad of r, grad of k over r, where k is a constant. So first, r is quite simply the magnitude of my position vector r, and this magnitude is exactly square root of x squared plus y squared plus z squared. We already seen this. If I want my grad in Cartesian coordinate here of my r is exactly, so grad itself by definition in Cartesian coordinates is exactly partial over partial x. If you have this, only grad I plus partial over partial y g plus partial over partial z k. And if I want, for example, grad of this r is exactly, so I have this here r and here r. So grad of r is exactly partial r over partial x I plus partial r over partial y g plus partial r over partial z k. I want to simplify this derivative. I have here this square root. If I want to simplify this derivative, I use to the power. That means square root of r x, which equals x squared plus y squared plus z squared, is exactly this quantity to the power of 1 over 2. To the power of 1 over 2. And this derivative, for example, partial over partial x, so it is the derivative of this quantity, all this quantity with respect to x, and I consider y and z constant. So is partial over partial x of this quantity. Okay, I have for you a very simple recall. If you want, for example, a certain function of x, du to the power n over dx, a certain function of one variable x equals exactly n du itself over dx, and don't forget times u to the power n minus 1. For example, I have for you a very simple example. X squared. D of x squared over dx is exactly 2 dx over dx itself, x to the power 2 minus 1, and it's exactly 2 times x. Okay, so here I have 1 over 2 partial over partial x of this quantity, just this quantity without this 1 over 2 of x squared plus y squared plus z squared, and don't forget x squared plus y squared plus z squared to the power of 1 over 2 minus 1. So here I have this to the power of 1 over 2 minus 1. Okay, 1 over 2 minus 1. So this partial derivative is exactly 2x because I consider my y and z constant. So I have 1 over 2 times 2x and 1 over 2 minus 1